When you ride a bicycle, your effort moves in a continuous circle. You push the pedals in a loop, and the wheels spin in response. Yet, despite all that rotation, the bicycle travels forward in a perfectly straight line. Every inch of progress depends on this conversion. The parts of the machine that move us are round, but the world we navigate is linear. You might have memorized the formula C equals pi times d to pass a geometry test, but to see how that rotation actually pushes you forward, we have to look past the symbols on the chalkboard and focus on the physical edge of the circle. We can see this mechanic clearly with something as simple as a tin can. If you wrap a piece of string around the outside edge of the can, you've captured its perimeter. When you peel that string off and lay it flat on a table, the curve disappears. That straightened length is the circumference. It is the exact measurement of a curve translated into a finite, measurable straight line. Now, apply that same unrolling process to a moving bicycle. Imagine placing a paint dot on the tire where it meets the road. As the wheel rolls, the dot travels up, over, and down until it touches the ground again, one full rotation. Look at the straight trail left behind between those 2 points. That distance is exactly equal to the circumference of the tire. If the wheel's circumference is 2 meters, 10 rotations will always move the bike exactly 20 meters. The wheel acts as a hidden measuring tape, tracking linear distance across the Earth with every spin. This same logic scales up from a bicycle tire to the ultimate sphere, Earth. If you were to trace a line all the way around the equator, you would find a circumference of approximately 40,000 kilometers. For centuries, sailors had to navigate vast, featureless oceans where there were absolutely no landmarks to measure distance against. By measuring the changing angles of the stars, navigators could determine what fraction of the Earth's 360-degree curve they had crossed. Knowing the world's total circumference, they could translate those celestial angles into actual kilometers traveled. Understanding circumference allowed humanity to map the curve of the globe onto these flat, navigable grids. Circumference is the mathematical bridge allowing us to measure our linear progress across a round world. Next time we look at diameter, the straight line that cuts directly through the middle. Don't just memorize the math.